Okay, so we finished our discussion about integration factor method. Right? So we did more examples. I hope we did more examples, right? So, and I'm planning to do a problem session before the exam. So we will discuss more problems. So we finished the discussion about integration factor method. So you have to remember few basic steps in this case, right? So the first thing is you have linear ordinary differential equation like this. 1x dy over dx plus a naught x y is equal to 3x. Then in this case, the coefficient of dy over dx is not equal to 0. The first step is make the coefficient of dy over dx to 1, right? So divide both sides by a 1x. So then you would get something like this, dy over dx plus a naught x divided by a 1x times y is equal to gx divided by a 1x. So this is kind of your fx and this is your px. Okay. So this is going to be your px and this is going to be your fx. Px. So now you have equation like this, dy over dx plus ex times y is equal to fx. Okay. After you reach this equation, then you have to find the integration factor, right? So then what is the integration factor? That is the exponential of integral dx dx. This is the integration factor. The next step is multiply both sides by integration factor, right? So integration factor dy over dx plus integration factor px times y is equal to integration factor times fx. Okay. Then we showed that this summation is equal to the derivative of integration factor times your dependent variable. Okay. It's equal to integration factor times fx. Okay. The derivative of this function is this one. So integration factor times y is going to be equal to integral of integration factor times fx plus the arbitrary constant. Okay. Then what I'm going to do, I'm dividing both sides by integration factor, or in other words, I'm going to multiply both sides by the power of -1 of integration factor, right? Then y is equal to inverse of integration factor integral factor fx x plus c times, right? This is what you have to do, right? So if you know the integration factor, that would determine everything, right? But do not use this formula directly in the exam, right? So I would check the procedure, right? You have to do all these steps, right? Do not remember this formula, right? Actually, you need to remember this trick, only this trick and how to find the integration factor. Those are the most important points, right? Okay, so today I would introduce Bernoulli substitution trick. Bernoulli, I have to spell that correctly. Bernoulli's substitution trick. Right? So now we know that we can solve first order linear differential equation, right? We can use integration factor method to solve first order linear differential equation. But what would happen if you have something like this? Suppose you have something like this. d by dx plus px times y. This term is also here, still it's linear, right? But now instead of having fx, I have fx times y to the power alpha. Okay? Alpha can be any real number, right? I have y to the power alpha. So y to the power alpha is a nonlinear function, and y is my dependent variable. Okay, y is my dependent variable, and you can see nonlinear operation has been performed on y. Or in other words, nonlinear operation has been performed on your dependent variable. Right? So this is a nonlinear differential equation, nonlinear ordinary differential equation. Okay, and its order is 1, so it's first order nonlinear ordinary differential equation, right? But we can convert this nonlinear equation to a linear equation by using a substitution. That's what I am going to do next. Okay, so this is the substitution that you have to do. So it's going to be u equals y to the power 1 minus f. Use u equals y to the power 1 minus alpha substitution. Okay. This is very important, right? So if you see some power of y, you can use this substitution, right? For example, suppose y equals 3, then the substitution is going to be u equals y to the power 1 minus 2. Okay, right. Now what can you say about the derivative of u with respect to x? Now we have to apply the chain rule to find the derivative of u with respect to x. It is going to be the derivative of y to the power 1 minus alpha with respect to x. Okay. Now I'm going to apply the chain rule. Okay. So how do you apply the chain rule? So this is going to be d over dy times y to the power 1 minus alpha times dy over dx. Okay. Right. How do you take the derivative of this function? Substitution. Yeah. You can directly substitute it, right? Yeah. Directly evaluate that. So you have to use this formula d over dx, x to the power n is equal to mx n minus 1. Okay. So I would get 1 minus alpha y to the power 1 minus alpha minus 1 dy over dx. Okay. Right. So this would become minus alpha, right? 1 to 1 would be cancelled, and you get y to the power minus alpha. So on my left hand side, I have du over dx. So du over dx is going to be equal to 1 minus alpha times y to the power minus alpha times dy over dx. Okay. Then I would subject dy over dx. So what is dy over dx? Dy over dx is going to be equal to y to the power alpha divided by 1 minus alpha and du over dx. Okay. I divided both sides by 1 minus alpha and I multiplied both sides by y to the power alpha. Okay. So this is dy over dx. Right. Any questions so far? I use this substitution and I'm going to convert this ODE to ODE whose dependent variable is u. Okay. In this case, its dependent variable is y. Okay. Now let's move on. Now I'm going to plug this expression instead of dy over dx. Okay. Let's see what will happen. Now instead of dy over dx, this is my original differential equation, right? I would call that equation as equation number 1. So substitute for 1. Then what would we get? Y to the power alpha divided by 1 minus alpha du over dx. That is dy over dx plus dx times y is equal to fx times y to the power alpha. Okay, right. Right. My next target is remove this y and this y to the power alpha, right? Because I would like to have a linear differential equation, right? So I'm going to do something like this. First, I would divide both sides by y to the power alpha. Okay, so let's see what would happen. Then I have 1 divided by 1 minus alpha du over dx here. If I divide this term by y to the power alpha, what would I get? Dx times y divided by y to the power alpha. I would get y to the power 1 minus alpha. Okay, I am dividing everything by y to the power alpha. So what would I get here? I would get it. Okay, is that clear? I divided each term by y to the power alpha. So this y to the alpha would disappear, and y divided by y to the power alpha would become y to the power 1 minus alpha here, and this y to the alpha also would be disappeared. Okay, right. Now what can you say about y to the power 1 minus alpha? That's 2. Right, that's our substitution. Right, so now this is u, so instead of y to the power 1 minus alpha, I would plug u. 1 divided by 1 minus alpha du over dx plus dx times u is equal to fx. Right. Next, I would multiply each term by 1 minus alpha. So then this 1 minus alpha would disappear, and I would get du over dx plus 1 minus alpha dx and u is equal to fx. Okay. Now what can we say about this differential equation? The linear first order ordinary differential equation, right? Because this is my independent variable and u is my dependent variable. There are no any nonlinear functions of u, right? Okay. Now, what is the method that we can use to solve this ODE?
First order.
That is the first order linear ordinary differential equation. So we can use the method that we discussed previously. We can use integration factor method to solve this. Okay, right. So we can use integration factor method. Okay. So can you find the integration factor of this ODE? What is the integration factor? What is the integration factor? Can you give a try to find the integration factor? Yeah, it should, yeah. 1 minus. Thank you. Now you can see this is kind of very similar to the differential equation that we discussed previously, right? So try to figure out what is the coefficient of your dependent variable, and then you can easily find the integration factor. Right? Integration factor. What is integration factor? Any guesses?
E to the x minus alpha x.
E to the integral.
X minus alpha x.
You have to be concerned about this kind of field. What is the coefficient of your dependent variable? It's this term, right? Remember we discussed this one, d by power dx, px times y is equal to f. If this is our differential equation, then integration factor is going to be e to the integral px dx. Okay, so we had to take the coefficient of your dependent variable. Right? In this case, the coefficient of my dependent variable is 1 minus alpha times px. Right? So my integration factor is going to be 1 minus alpha times px.
More or less 1 minus alpha is a constant.
Yeah, it's a constant, you can take that out.
So it would be e to the px.
e to the 1 minus alpha times integral of dx, because integral sign is here, right? Okay, right. Now we know the integration factor, right? So we can apply integration factor method, then we can find the solution, right? That means we can find u. Okay, we can find u by using the integration factor method, right? So we can find u by using integration factor method. Suppose we found u, then what is the next step? Our final target is finding y, right? Because y was our main target. So then we know that y u equals y to the power 1 minus alpha. So y is going to be equal to u to the power 1 over 1 minus alpha, right? So everything would be okay after we found u. Okay, right. Let's do an example, right? Example, that is logistic equation. Consider the equation dp over dt is equal to t times 1 minus capital P divided by C. Okay. Oh, I would use lambda. Lambda, right? You can see that this is a non-linear differential equation, because if you multiply or if you simplify this bracket, you would get P square, right? So this is, so you can use this Bernoulli structure. So can you figure out the method? So let's try to figure out what is the suitable substitution, right? Can you do a try? I will give you around 3 or 4 minutes. Let's try to simplify it. You have k times p minus k times p square divided by lambda, right? Then take the kp to your left hand side, right? Then you can see something. Right. So I would take this kp into left hand side. Okay. Then I have dp over dt minus k times p is equal to minus k divided by lambda times p square. Okay. Now what can you say about this equation? Is it linear or nonlinear? Nonlinear, right? Because p square is the period. P is my dependent variable and its square is the period. Okay. Suppose you do not have p square, then what can you say? Then it's linear, right? And you can apply integration factor method. But now p square is the period. So you can apply the Bernoulli trick, right? So instead of alpha, what would you have here? Instead of alpha. Because in Bernoulli's equation, so we saw that we had fx times y to the power alpha. Now instead of alpha, what would we have? 2, right? Okay, so what is our substitution? U is going to be, instead of y, I have p to the power 1 minus 2. Okay. That is U equals p to the power negative 1. Okay. Now, the next step is we have to convert this differential equation into another differential equation. That would be linear, and its dependent variable should be u. Can you try to do that step? For that, you have to take the derivative of u with respect to t. Okay. What is du over dt? Apply the chain rule, right? Du over dt is equal to d over dp times p plus dp over dt. Okay, so this one is going to be negative 1 times p to the power negative 1 dp over dt. So du over dt is equal to negative p to the power negative 2 times dp over dt. Okay. Now this is the original differential equation, right? Can you subject dp over dt and can you do the substitution here? And can you try to obtain a linear differential equation of u? That's our target, right? Try to obtain a linear differential equation whose dependent variable is u. Did anyone get the linear differential equation? This is du over dt. So what is dp over dt? So I obtained that du over dt is equal to negative p to the negative 2 dp over dt. So what is dp over dt? That is negative p square du over dt. Right? I would multiply both sides by negative sign as well as p to the power 2. Right? Then I would keep this. Right. Now this is dp over dt. Now I would go back to equation number 1, my original differential equation. That is dp over dt minus k times p is equal to minus k times p square divided by lambda. Okay. Now let's plug this one. Right. dp over dt is this one. So negative p square du over dt. times p is equal to negative k times p square divided by 11. Okay,
Did you mean to make that a positive two as opposed to a negative two?
this one,
Yeah, on the very top, you have,
this one.
yeah,
That happened because this was my original equation.
and you moved it.
I multiplied both sides by p square.
Oh,
Right, so then this would become p square du over dt. This would become negative 1 times dp over dt. Okay. Right. Now you can see this negative sign would be cancelled out, right? And we have positive terms. And I would divide each term by negative p square. Right. Then what would happen? I would divide this term by negative p square, so I have du over dt. Okay. Then I would divide this term by negative p square. So I have negative kp divided by negative p square. I would divide this term by negative p square, then I have k divided by capital. Because I am dividing by negative p square, so this sign would be cancelled, p square would be cancelled. Okay. And this would be also would become positive, right? So at the end I would get du over dt plus kp divided by p square, that is k times p to the e. K times p to the power negative 1 is equal to simple k divided by lambda. Okay. But what is p inverse of p to the power negative 1, that is equal to simple u. Okay. So I have du over dt plus k times u is equal to k divided by lambda. Okay. This is what I have. Now what can you say about this equation? Now we have a nice linear ordinary differential equation, right? Because this is a constant and I have ku du over dt. Now we can solve this easily, right? This is not a difficult ODE to solve, right? Because integration factor would be very easy, right? Because I have only a constant, right? So now let's use integration factor method and let's solve for u. Right. So what is my integration factor? That is e to the power integral of px. Instead of px, now we have k. Okay. So integration factor is going to be e to the power kt. So after we found the integration factor, what would be the next step? Multiply both sides by that. Right? So I multiply both sides by e to the power kt. So I have e to the power kt du over dt plus e to the power kt times ku equal to e to the power k3 k divided by lambda. Okay. Then I'm using the usual trick. The summation is going to be the derivative of integration factor times the dependent variable, that is u, equal to e to the kt k divided by lambda. Okay. Right. Then derivative of this function is going to be this one. So e to the kt times u is going to be equal to integral of e to the kt K divided by lambda plus this constant. Okay. So K divided by lambda is a constant, and the integral of e to the kt is e to the kt divided by q. So K would be cancelled, and I would get e to the power kt divided by lambda plus c. So this is e to the kt times u. Okay. Then I can divide both sides by e to the kt. Or I can multiply both sides by e to the power minus kt. Okay. Then what would I get? I would get u equals e to the power minus kt e to the power kt divided by lambda plus c equal to, I'm multiplying by e to the negative kt, so this would become 1 divided by lambda plus c times e to the negative kt divided by, no, that's all, c times e to the negative kt. With u, right? But this is not our main target, right? Our main target is to find p, right? But we know that u equals p inverse. Okay, so you can easily find p, right? Let's start. We know that u is equal to 1 over lambda plus c times e to the negative p, and our substitution was u equals p inverse. Okay. Right. So in other words, 1 over p inverse, right? So what is p? P is equal to 1 over u. So p is going to be equal to 1 over u. U is equal to 1 over lambda plus c times e to the negative. This is the solution for logistic equation, right? P is the population at time t, or population after t years. Okay, so the idea is we can use the Bernoulli trick to solve the logistic equation. Logistic equation is not a linear equation, it's non-linear, but it's a special kind of non-linear body, right? Because it would be like this: dy over dx dx times y equals fx times y. As if we have this kind of non-linear equation, we can solve it. Okay, so this is a special category of nonlinear equations. Okay, right. So now you can see if nonlinear terms are going to appear, then the procedure is going to be very hard, right? So we can solve some special scenarios, but we cannot solve most of them, right? That's the idea. Right. So any questions about Bernoulli trick? So it's again, it's also same integration factor method, but the only new idea is you need to use some substitution and construct a linear ODE. Right? That's what you have to do. Right. Okay. So shall we move on? I'll introduce exact differential equations and then we'll go to break. Have you seen partial differential not equation, partial derivatives. If you have taken calculus, you might have seen. Right? Have you all taken calculus? Okay. I would introduce them, so if you can't remember, you can recall your knowledge. Right. So my next topic is going to be exact differential equations. For that, we need to recall our knowledge about partial derivatives. So, if you have one independent variable, you are using derivatives, right? The problem is, what would happen if you have more than one independent variable? For example, suppose you have a function of two variables, right? Suppose you have function of two variables. Right? I will call that function as fxr. So if it's a function, and its value would be depend on both of these variables. Okay. So you cannot sketch this function in a two-dimensional plane, right? You need three-dimensional. Right. So first I would take the partial derivative of this function f with respect to x. What is the meaning of this? What is the meaning of dava f over dava x? The idea is you think that y is constant and you vary x, right? You give a little change to x and you would check what is going to happen to x, right? Okay, write this mathematical limit delta x goes to 0 if I would change it to x plus delta x. And I would not do anything for y, right? Minus delta x divided by delta x. Okay. I changed the variable x by delta x amount, right? And I'm going to check what would happen to this ratio. Right? This is called as partial derivative of f with respect to x. Right? Similarly, what is the upper f over w? Now you think x is a constant and you change y. Right? Limit delta y goes to 0 if x y plus delta y minus x y are the partial derivatives of f with respect to x and y. In general, you might have some functions of n variables, right? Suppose f is a function of variables x1, x2, xn, right? Then you can define n partial derivatives. Okay. Suppose you have function of n variables. Means f is a function from Rn to R. Okay. So you have n tuples here. So you would take some x1, x2, xn, and under this function, this would be mapped to f x1, xn. Okay. Then for this function, you can define n partial derivatives. First one is da by f over da by x1. In this case, you think that you would change x1 a little bit, right? And you would not do anything for other variables. Okay. Da by 4, da by x2, da by 4, da by xn. Okay. Then I would like to introduce another small thing, that's total differential. Total differential. Have you heard this term? Total differential. Again, first I would explain for the case of two variables, and then I would go to n variables, right? Suppose you have a function from R2 to R. Okay, that means you have xy, this would be mapped to fxy. Okay. The total differential is this. df is equal to da by f over da by x dx plus da by f over da by y dy. That means the change, in this case we have two independent variables. So change of your function, df represents change of your function. That would depend on two things, right? The first thing is the change of x and change of y. That's how this derives. Okay. Similarly, if we have n variables, R into R, your df is going to be, suppose your variables are x1, x2, xn. It could be mapped to x1, x2, xn. Okay. Then this is how you define the total differential. The f is going to be equal to da by f over da by x1 dx1. Da by f over da by x2 dx2. Da by f over da by xn dxn. Okay. Let's do an example. Right. Suppose we have a function of three variables. Suppose f is from R3 to R. Right. So I will define f in say xy z is equal to x cube plus 3 x square y plus 2 y square z plus z to the power 3. Right. Part A is find da by f over x. Part B is find r by 4 gamma y. Part C is find r by 4 gamma z. And part D is find total differential. Okay. This part is not mentioned in the lecture notes, right? It assumes that you know these things, but I would like to recall them, right? Because in this course I have more time, right? Actually, you do not need to apply this definition, right? Because you can take when you're finding the partial derivative with respect to a, think y and z are constants, right? And take the derivative with respect to x. Right? Now by 4 now by x. You think y and z are constant, and let's take the derivative with respect to x. So this will be 3 times x square plus 3 times the derivative of x square is 2x. 2x times y plus what is the derivative of this with respect to 0? No? This one is also. So I have 3 times x square plus 6xy. Okay? Right. This part B. Double by 4 double by. So, right. Now I think x and z are constants, and I would take the derivatives with respect to y. So the derivative of this one is 0, right? Because I am considering y. And if you take the derivative of this one, what would you get? 3x square, right? 3x square plus 2 times derivative of y square is 2y times equal, and derivative of z to the power 3 is 0. 3x square plus 4y. Okay. Right. So what is da by 4 da by z? Now think x and y are constants and take the derivatives with respect to z. Right. So this is the constant with respect to z. So 0. Derivative of this guy is 0. So what is the derivative of this one? It is 2 times y square. Right. And the derivative of this one is 3 times z square. Okay. Simple, right? Again taking the derivatives, but if you are taking the derivative, if you are taking the partial derivative with respect to x, then think y and z are constants. Okay. What is the total differential? dx is going to be dou by f4 dou by x times dx plus dou by f4 dou by y times dy plus dou by f4 dou by z times dz, right? Dou by 4 dou by x is going to be 3x square plus 6xy, 3x square plus 6xy dx plus that is 3x square plus 4yz right plus 2y square plus 3z square. Okay. Right. Any questions about these basics? All right. Okay. Now I'm in a good position to move into exact differential equations, right? So let's take a break, 4-minute break, and we'll continue. Everyone is here? Okay, let's see. Exact differential equations. Right. Suppose to have an equation of this type. The differential equation is mxy x plus mxy dy equals 0 is said to be exact if gamma m over gamma y equal to gamma n over gamma x. This is the condition that needs to be satisfied. Okay. Gamma m over m is with x, so we are taking partial derivative of x with respect to y. Right? I will give you an example, but this is the idea, right? We have a differential form like this. So, and this should be satisfied, right? Then we can solve this differential equation, and then the solution to this equation is something like this. Fx right is some constant, c is the constant, right? Okay. I will give you an example. The example that is given in the notes is radioactive decay. dA over dt is minus k times A. Right. Well, consider this equation. dA over dt is equal to minus k times A. Right? But we have to convert this equation to something like this. Okay, let's do that conversion. So I would take dt to the other side. So dA is going to be equal to minus k, right? Kt dt. Then I would take this term into this side. dA plus kt dt is equal to 0. Okay. Now you can see something like this, right? Instead of m, you have 1. I have 1 times dA plus kt times dt is equal to 0. So instead of m and n, I have 1 and kt, and instead of x and y, I have a and t. Okay. So now, right. Now you have to take the derivative of 1 with respect to what? T, right? Because 1 is with dA, so you have to take the derivative of 1 with respect to. So I would call this 1 as m. This is n. Okay. This is your m. This is your n. Okay. So what is delta m over delta t? This is equal to 0. Right? Because 1 is the constant. Right. what is DABA n over DABA a. What can I say about this? Now, a is the function of t, right? A is the function of t. What can I say about partial derivative of n with respect to a? A is a function of t. So, n is kd. Can you say? This is not going to be equal to 0, right? Because a is a function of t and we are taking the derivative of k with respect to it. So this is not an exact differential equation, right? Because this condition needs to be satisfied. Okay, right. Let's move to the other one. I have written the question incorrectly. It should be a. It should be a. I would redo that again. Right. So this is the equation for radioactive dt, right? So I would take dt. So dA is equal to minus Ka dt. Okay. Then now next step is dA plus Ka dt is equal to 0. Right? Now this is my m and this is my m. Okay. So one is appearing with a, so I would take the derivative of m with respect to t, that is equal to 0. Right? And then n over DABA a is equal to DABA over DABA a times k. I would get k. Okay. What can you say about the exactness of this? This is not an exact equation, right? Because these two should be equal. If this is an exact equation, these two should be equal, right? DABA m over DABA t should be equal to DABA n over DABA a. And we'll take into the other side in the initial state. Okay. Can you divide from this side and get it from this side? Yeah, then this will become an exact equation. Yeah, that's what I'm going to challenge. Yeah. So because based on the way that we are going to simplify, the exactness would change. Right? So if we consider this one, this is not going to be an exact one, right? But let's do something like this. As he mentioned, if we divide both sides by a at the initial stage, then I have 1 over a dA over dt is equal to minus k. Okay, I divided both sides by, this is kind of next example. Okay, next I would take dt to other side. So now I have 1 over a dA is equal to minus k dt. Right? Have 1 over a dA plus k dt is equal to 0. So now this is your m and this is your n. Okay. So dou by m over dou by t is equal to dou by over dou by t 1 over 8. These two are two different variables. This is going to be equal to 0. And dou by n over dou by a is dou by over dou by a times k, and it's also equal to 0. Okay. Because in this case, a and t are my variables, right? So when I'm taking partial derivative with respect to it, I would consider a as a constant, and when I'm taking the partial derivatives with respect to a, I would consider t as a constant, right? Okay, now this is exact. This is exact. This would tell you very important fact. That is, at what condition can you do this division? If a is not equal to 0, right? If a is not equal to 0, you can divide both sides by a, right? So then the equation is going to be exact. Okay. But if not, you cannot do this division, right? Suppose we do not know anything about a, then we cannot do this division, and then it is not exact, right? So this idea is very important, right? So this idea is connected to complex analysis also, because this idea is used when identifying the holes in this space. This idea is going to be very important, right? Okay. Right. So let's move into another example. So we should know what is going to happen to this a in our domain, right? So my next example is, so in the problem, sometimes it is not given, but remember that fact, right? Next example is, consider dy over dx equals 1 minus dx 3y plus. Okay. So yeah, remember that it cannot be equal to 1 over 2, right? And y cannot be equal to negative 2 over 3. In this case, that condition would be enough. Y cannot be equal to negative 2 over 3. Okay. Let's try to solve this, right? Because in these two examples, we checked only exactness. Let's try to solve this. Okay. First, I would construct an equation of this type. Okay. So I would take 3y plus 2 side, and I would take dx into the other side. I have this. Okay. Then I would take this one. So I have 1 minus 2x dx minus 3y plus 2 dy equals 0. Okay. This is kind of your m. This is your n with negative sign. Okay. What can you say about dou by m over dou by x, dou by y, and dou by n over dou by x? what is the derivative of m with respect to y? Now m consists of x, right? So if you take the derivative of m with respect to y, it is going to be 0. And if you consider n, it consists of y. So if you take the derivative of n with respect to x, it is also going to be 0. Okay. So this is exact. Now we know that the solution to this differential equation is going to be look like something like this. Fxy is equal to c. That's our theorem, right? If a differential equation is an exact equation, it has a solution like this. Okay. Right. So how do you find solution? So this is the idea. So this is our solution. So there are a few steps that we have to go through. But we know that the solution is something like this, right? So what can you say about df? The differential of it. F is always a constant, right? So df is 0. Okay. df is equal to 0. What is df? Dou by f dou by x dx plus dou by 4 dou by y times dy equal to 0. Okay. Right. Now can you see some relationship between these two? One and two. Can you see some relationship between one and two? They are same, right? So what does one say? 1 minus 2x equals plus minus 3y minus 2 dy equals 0. Okay. If you relate them, what can you say? Partial derivative of f with respect to x is going to be 1 minus 2x, and partial derivative of f with respect to y is going to be minus 3y minus 2. Okay. This is very important fact, right? Because this is our theorem. If this is a exact differential, then its solution would look like this, right? So since solution is constant function, the differential equals 0, right? So I related these two ideas. Okay, now let's try to solve this. Now we have these two equations, and now we have to solve this. Yeah. Let's begin with this one. Right, so let's consider dou by 4 dou by x is equal to 1 minus 2x. Okay, right. I know that partial derivative of f with respect to x is going to be 1 minus 2x. So what can you say about fx? What can you say about fx? If you take the derivative of f, you get this one. So what can you say about fx? You need to integrate, right? So you need to integrate 1 minus 2x with respect to x, but you get another term. What is that? Is that a constant or something else? Is that a constant or something else? It is not a constant because this is not a derivative, right? If this is the derivative, then it would be a constant. Now, because we are thinking that any function of y is a constant, right? So in this case, the constant would be a function of y. Okay. If you are not sure, go in the reverse direction. Take the partial derivatives of, let's integrate this. So first, so I will get x minus x square plus gy, right? Take the derivative of this one, what would you get? Take the derivative of this function with respect to x, what would you get? If you take the derivative of that function with respect to x, you get this one, right? So if you put c here, then it would be wrong, right? It should be a function of y. Okay. It might be constant, we don't know, but in general, it should be a function of y. Okay. Right. Now, if we can find gy, then we are done. Okay. Right. So let's move to find gy. Okay. What can I use? I use this idea, but I have another unused equation. I'm going to use this. Okay. I know that. Da by 4 da by y is equal to 3y minus 2. Okay. Right. So this is one way of expressing da by 4 da by y. Can you find another way of expressing da by 4 da by y? This one, right? Because we know it, right? So what is the other way of expressing da by 4 da by y? That is by using this x minus x square plus gy, right? So what would you get? We are taking the derivatives with respect to y, so this guy would be 0, this guy would be 0. I would get g dash 1 because g is a function that whose variable is 1. Okay. Now I can equate these two. Okay, because I know that on the one hand I know that da by 4 da by y equals negative 3y negative 2, and on the other hand I know that da by 4 da by y equals g dash 1. Okay, so I know that g dash y is equal to 3y minus 2. Okay, right. Okay, now we can take this integral, right? Now g is a function of y, right? So what can you say about gy? Gy is going to be integral of 3y minus 2 plus c. So that is 3y square divided by 2 minus 2y plus the constant. Okay. Right. Now I found gy, so I can write fxy. Fxy is going to be equal to x minus x square plus 3y square divided by 2 minus 2y. Okay. But f is a constant, right? So instead of c, I would do c1. I know that f is a constant, so this is going to be equal to another constant. See, so at the end I get x. At the end I would get x minus x square 3y square divided by 2 minus 2y is equal to c minus c1, that is, I call that as k. Right, so this is going to be the solution. Okay, so this is going to be a surface on surface. So yeah, I think it's minus x square. This is going to be a curve in 3-dimensional. In 3 dimensions. let's do more examples on this idea, right? Because I think this is the hardest part that we discussed so far. Right. So did you get some idea? We'll do more examples. But what is the example they ready? For what? 3y plus 2, right? Okay. Okay. Now let's do a different one. d5 over x is equal to y times sine x minus sine y divided by cosine x plus x times cosine y minus 1. Let's try to solve it. First, check whether this is going to be an exact equation or not, right? Can you check that? That is the easiest part, right? That's not a hard part. What do you think about this course? Is this harder than calculus? Than calculus?
Trying to plug in geometry, trigonometry, calculus, and I don't remember always one of those is part of the problem.
Yeah. Because we are using Cal 2 and Cal 3, right? Cal 1, Cal 2, and Cal 3. Is this an exact equation? Just check the partial derivatives, right? So what would you get? Cosine of x plus x times cosine of y minus y dy equals y sine x minus sine y dx. Then I would take this into the other side, or I will take this one into that side. So I have y times sine of x minus sine of y dx minus cosine of x plus x times cosine of y minus y dy is equal to 0. I would multiply negative sign, multiply by negative sign. So I would get y times sine of x minus sine of y dx plus minus cosine x minus x times cosine y plus y. Y is equal to 0. Okay, right. So this is your m. This is your m. Right. Take the partial derivative of m with respect to y and take the partial derivative of n with respect to x. Right. And check whether those two things are equal or not. Right. That's right. Equal to y sine x minus sine y. Find delta m over delta y. Take the derivative of m with respect to y. Okay, so what would you get? You are taking the derivative with respect to y, so this would be a constant. So you get sin x here minus cosine y. Okay, so it's nxy. Nxy is going to be negative cosine x and negative x times cosine y plus y. Now take the derivative of n with respect to x. Okay, right. Now what is the derivative of cosine x? It is negative sine x. And now y is going to be a constant, so cosine y is acting as a constant. So derivative of x is going to be 1, so negative cosine y. Right. And derivative of y with respect to x is going to be 0. So what would I get? Sin x minus cosine y. Okay, so those two are equal, right? So delta m over delta y is equal to delta n over delta x. So this equation is an exact equation. Right. Now let's move to the difficult part, right? Now we check the exactness. So we know that the solution is going to be something like fxy equals c. So solution is fxy equals c. See, so we need to find fxy. Okay. And we know that since the solution is a constant function, we know that the total differential equals 0. Delta f over delta x dx plus delta f over delta y dy is equal to 0. Okay. On the other hand, I have this one, m dx plus n dy equals 0. So what is m and what is n? So m is going to be del by 4 del by x and n is going to be del by 4 del by y. Okay. The other hand, I have m dx plus n dy equal to 0. So this would imply that del by f over del by x is equal to m, which is equal to y sin x minus sin y. Okay, and del by f over del by y is equal to n, which is equal to sin x minus cosine y. Sin x. Oh, I did a mistake. M is going to be not this one, right? But it's m. It's correct, but n is incorrect. Right? M is y times sine x minus sine y. What is n negative cosine x negative x times cosine y plus 1. Okay. First, you can use any of you can start with this one or this one, right? Start with either of this and try to get an expression for it. Right? Integrate the easier one. This one is this one has two terms, so go with this one. Start with this. I think we might not get enough time to solve this. So, can you try this at home? So, tomorrow I would start from this point. Okay. You have to do first integrate this one, so then you get gy, and then try to use this. Then, as I did in the previous example, then you can find gy. Okay. Right. So, let's do more examples on exact differential equations on tomorrow. Right. And tomorrow is Wednesday, right? Yeah, I think on Thursday I would be able to finish this section, and on Friday we'll do a problem discussion. Okay. And on next week we're going to start Laplace transform. Right. That is the most interesting part of this course.